Okay, let's try another. Here we have x equals y squared plus 1. X equals y squared plus 1. We're going to see if it has symmetry with respect, again, to the x-axis. We'll see if it has symmetry with respect to the y-axis. And remember what happened in the last example. We ended up having 3 yeses. So just because we have symmetry with respect to one doesn't mean that we stop checking for the others. So remember, when you have symmetry with respect to the x-axis, you're going to leave x alone and you're going to replace y with negative y. And then we simplify. A negative times itself is positive. So we have x equals y squared plus 1, which is the original equation. Therefore, we have x-axis symmetry. Perfect. Now let's try y-axis symmetry. Remember, we're going to leave y alone, and we're going to put a negative in for x. So negative x equals y squared plus 1. Okay. In order to make this look like the original equation, I'm going to have to multiply everything by a negative. So that's going to give me positive x. And then when I multiply this term by a negative, I get negative y squared. And then positive 1 becomes a negative 1. So that is not the same equation. So that is not the original equation. It's the exact opposite of the original equation. So this is not y-axis symmetry. Okay, let's try with respect to the origin. So we'll have a negative going in for x and a negative going in for y. So negative x equals y squared plus 1. Well, that's what we had over there in blue. So we multiplied everything by a negative. So each term changed its sign. And this again is not the same or original equation. Therefore, not symmetric with respect to the origin. So I'm trying to write this just a few different ways so that you can see what it might look like depending on the resource that you're given. When it's symmetric to the y-axis only, when you have symmetry with respect to the y-axis only, then you have an even function. So this is very, very important. Then you have an even function. So then it's an even function. And when you have symmetry with respect to the origin only, then you have an odd function. So if it's a combination, we're not talking about even and odd functions. When it's the y-axis only, you have an even function, and when it's the origin only, you have an odd function. So here are 3 examples that we're going to come back and do in the next video. So you can take a look at it in advance and then come back and see what your answers compared to mine, or you can just come back and work them out with me in the next video.